Hello, welcome back. I'm still Matt McSpirit.
Still Corey Hines.
Yep, and we're focused on the Windows Server 2016 preview. Now, in the previous module, we looked at virtualization after a brief introduction. Hopefully you found that useful. If you haven't seen it, make sure you go back and check it out. And in this module, we're going to be all focused on storage. Module 3, all about software-defined storage. And you might be thinking, well, what is software-defined storage? Well, we're going to tell you. We're going to go through a little bit of what's in 2012 R2, because as Corey said, this module, perhaps more than any, you need to understand just what we did introduce so that the new stuff makes sense. If we just introduce Spaces Direct, it wouldn't have context about where it's come from. And the options introduced today in 2012 R2 are still very relevant going forward in 2016 as well. So we're going to talk about all that stuff: Spaces Direct, quality of service, dedupe, save you some storage space, replication, so another type of replication, different from Hyper-V Replica. I'd go as far to say this one is even cooler. Would you agree?
I wasn't listening, sorry.
No, you weren't.
I was looking at the QA. I was looking at the QA.
I was looking at you, looking at your fancy watch. We'll talk about Azure Consistent Storage, and I've got some resources and links in there. We won't spend time on that.
What was the question, honestly? What was the question?
Would you say that Storage Replica is cooler than Hyper-V Replica?
I would. I would.
OK, great. You didn't have enough time there, sorry.
Is this Jeopardy?
What is software-defined storage? There you go, that's a Jeopardy-style question, isn't it? So what is software-defined storage?
There's other game shows besides Jeopardy.
Excellent, yeah, that's right, true. So to introduce, and just going to spend a minute or two before we dive into the technology. So software-defined storage is essentially using the power of software, like Windows Server, to transform industry-standard hardware. So regular x86 servers, processors, memory, local disk or remote JBOD storage, whatever it may be, and transforming that into a storage infrastructure that enables you to deliver high performance, redundancy, scale, reliability, replication, deduplication, thin provisioning, all the features that you expect from a more traditional storage platform like a SAN, for instance. And the reason we're embracing software-defined storage in Windows Server is essentially we're utilizing the design patterns in Azure and integrating those design points into Windows Server, which drives down the cost of storage because we're utilizing local storage, low-cost commodity, high-volume hardware. We're using this storage backend to meet the demands of growing data in the infrastructure, because a lot of people's data is just growing and growing and growing, so their needs for storage are growing and growing. And if that's an expensive line item on your bill of materials, then we can help with software-defined storage to reduce that cost. And we can take advantage of evolving technologies like Flash, like the network, so it can nicely integrate with what you've got today. And it's a great platform to run virtual machines and, going forward, containers. And because it's all handled in software, it means we can rapidly scale with simplicity through efficient management tools like System Center, like Windows Server GUIs, and also like PowerShell. So that's a bit about what is software-defined storage, and more of it will come to life as we go forward and we demonstrate some of this. But where does it fit in the bigger picture? Well, there are going to be plenty of organizations out there who still choose to deploy on SAN storage or NAS-based storage, and that's fine. That's fine. There's integration points with Windows Server and with System Center for managing those more traditional storage infrastructures. Then there's the private cloud on a Microsoft platform where you're utilizing software-defined storage throughout Windows Server, throughout the Azure stack. Then you've got hybrid cloud storage where you're offloading certain pieces of data into the cloud when it's cold, when it's not used. And that's a technology known as Store Simple that integrates with cloud-based storage like Azure specifically. So keeps some storage that's actively used and frequently used on premises, and the rest that's cold and not been used very frequently is tiered off into Azure. It becomes almost like in addition to SSD and hard drive tiering within the appliances, Store Simple also includes your cloud tier, essentially, and automatically moves data between those tiers depending on how hot that data is. And then you've got Azure storage in the cloud within Microsoft data centers. And all of that is within the Microsoft stack. That is all the offerings Microsoft has. We're going to focus specifically on that second from the left, that Microsoft software-defined storage. So the story so far, where have we been? Well, essentially, we're talking about Windows Server transforming commodity x86 industry standard hardware. So you'll see there numbers 2 and 3 and 4. We're essentially saying, OK, connect a couple of physical file servers. So this isn't your file server of yesteryear. This is a powerful storage infrastructure. Connect 2 to, I think, 8 is the max in 2012 R2, file servers in a cluster. And to those, connect some shared JBOD storage, so just a bunch of disks, chassis containing hard drives, SSDs, connected via industry standard SAS. So the cost of that solution is significantly lower than traditional SAN infrastructure. And that builds your scale-out file server cluster. So you've essentially constructed an infrastructure that is accessible via / storage cluster, whatever you want to call it. And it's accessible over the SMB3 protocol network fabric. So I said before, it integrates nicely with your existing network. If you want to introduce a scale-out file server, you've already got the network infrastructure. You can use the ACLs you're familiar with to control access to this file server. And in this case, in the graphic, we would ACL the scale-out file server to that Hyper-V cluster that sits at the top there.
So, to kind of give you a little bit of a comparison, the tasks you're talking about doing would ordinarily have been done if you go back to fiber channel. I administered a bunch of fiber channel in my life, and it's things like zoning fiber channel to make sure that this LUN on this array is available to this server.
Yep.
And what this is letting you do is say, we're not going to do that anymore. We're just going to have a file share. And the way we assign a LUN or a zone to a server is a permission.
Yep.
And so all those tasks that a Windows administrator is used to doing, permissions, files, shares, now are used to manage enterprise-grade storage.
Yeah.
And so that's where your skill set as administrator now gets to expand and include things like storage and networking using that same set of skills you have for traditional Windows administration, including PowerShell.
Yep, there you go. And you mentioned enterprise-grade storage infrastructure, and to be enterprise-grade, it's going to have the enterprise features that you're looking for as well. So things like storage tiering, thin provisioning, deduplication, all of those, and combine that with some of the things you've seen already, like REFS, and you can see how it's going to provide the high performance and scale to meet the needs of your infrastructure. And if we advance a little bit and look specifically at one feature called storage spaces, this is the magic that does virtualize the storage. So essentially from your JBOD, you're just a bunch of disks where you've got your hard drives, your SSDs, you've presented those through SAS to a couple or more scale-out file servers, again, industry standard x86 servers, and they're in a storage pool. And you combine those those physical hard disks, SSDs, and hard drives, and slice them into spaces, and those spaces become almost like LUNs, if you will, that on top you create volumes and then store your file share accessed materials, your virtual hard disks, your virtual machines, whatever it may be. So combining the hard drives and SSDs for tiering, so hot blocks sit on the SSDs, cold blocks sit on the hard drives. Great for performance, great for scale, but you've got the hard drives for that capacity. It's flexible because I can add more JBODs if I need to grow, or I can add more file servers if I need to handle more demand. It's redundant because we can handle multiple enclosure failures, depending on how many enclosures you've got, how many JBODs. And it's redundant from a scale-out file server node perspective because it's a cluster. Should you lose one scale-out file server node, another takes over.
One of my favorite new toys is the file server cluster in a box.
Nice.
And there's a lot of companies that are selling these. You can just go ahead, give me your cluster in a box. All the major hardware manufacturers sell these things now.
Yep.
And it's a couple of the units we've bought are literally 2Us, and in the front of the 2Us are 24 SSDs. Inside the cases are all the big, thick, slow hard drives, and then on the very back are 2 little servers that are mounted in the back.
Yep.
And all that's connecting it together is a 12 gig SAS bus. And we're getting these for fraction of the price of building a traditional fiber channel or iSCSI cluster where you have external storage provided by a storage vendor, and then normal hardware nodes. And it's just it's less power, it's less time, it's less energy. I just absolutely love the things.
Cool. Yeah. And that's not only do we provide those, our partners provide those compelling solutions and utilizing that software-defined storage from Microsoft inside, but there's also additional features and functionality that we did introduce in 2012 R2. Things like quality of service to ensure that noisy neighbor virtual machines don't consume all of the IOPS. But it wasn't as granular in terms of its control and its administration as we would like, and that's why it's been significantly enhanced in 2016, and we'll talk about that shortly. But there was also features for deduplication to enable you to reduce your consumption of storage within your environment, and that could be for any volume, very easy to administer. But we'll talk about how 2016 has enhanced that from an optimization perspective.
And again, these are things that you traditionally would only get when you spent a lot of money on a big dedicated SAN enclosure. So these features like vDisks and dedupe and tiering and whatnot, you had to buy Windows and configure Windows, and then buy clustering hardware, and then buy fiber channel or iSCSI, and then buy a storage enclosure. and then get training on the storage. It became a big investment in time, energy, and money. Now, Windows exposes all of these functions, which is fantastic. So you get these just on a plain old Windows server, and we're going to see some of this here in a second.
Yeah. Now, if you think about who's doing this, are there I mean, Corey's obviously doing it. There are lots of organizations out there, and you can see just some of the customer stories that we've got links to in the slides. We're getting storage performance of 450,000 IOPS and roughly a gigabyte per second in throughput, more than 20 times the IOPS and 4 times the throughput of their SAN. Obviously, they may have been replacing an older SAN, but still, that's not to say that storage spaces can't deliver that high level of performance. And then in the past, the cost per terabyte dropped by significantly, $3,000 to $300, and they're just 2 examples. So, where are we going now in the future in 2016? So architecturally, we just talked about a configuration with storage spaces in the scale-out file server where you had an external JBOD connected to the file server nodes via SAS. So there's multiple layers there. Not complex, not necessarily expensive, but just extra layers.
We can make it simpler.
We can make it simpler, yeah. You're going to steal my thunder here, aren't you? You're just too excited. Calm down. Your watch will be going off again. So you've got your JBODs full of disks, SAS to the scale-out file server nodes. That is your scale-out file server configuration. Lots of layers, quite a few U consumed in the rack, depending on how big your JBODs are, obviously. But we said we can make it simpler. So a design point is saying, okay, how can we converge that separate JBOD and those scale-out file server nodes into one? So instead of having file server nodes that just have essentially CPU memory and an OS disk, and the JBODs are separate, take all those disks and put them in the chassis of the file server nodes themselves. And that's what this graphic illustrates. You've got your scale-out file server cluster, but the JBOD has disappeared because we've put the physical disk, both HDDs, SSDs, and they could be SATA, NVMe SSDs, so non-volatile memory. They could be inside these scale-out file server nodes, multiple you would traditionally have. You wouldn't typically just have one disk. And we will create the scale-out file server using storage spaces that distributes across those file server nodes. So no need for external storage for those nodes.
Now, one of the things that, again, to kind of point out and make sure you're kind of clear on this is that there's nothing shared between these nodes. Right? I'm literally taking a server with locally attached disks, and I'm saying, here's 4 servers. Each server has 10 disks, and I now have a cluster. One way I describe this concept is it's RAID at the server level. So rather than having 4 disks and doing RAID across the 4 disks, you have 4 servers and do RAID across the 4 servers.
Yeah.
And those 4 servers present themselves as a cluster. So it is literally shared nothing clustering.
So to the Hyper-V cluster that's on the slide here, it looks and feels similar to what it saw before. It's still consuming // storage. Yeah, / file share.
It doesn't care how that share is presented behind the scenes. It's just a file share.
Correct, yeah. So, but now you as the administrator and the storage specialist, you've actually consolidated and converged a complete layer there. And you're delivering now great storage for virtual machines, great for backup replication. Now that's a converged configuration where we've converged the disks from the JBOD inside the chassis of the file servers themselves. But could you then converge one more layer and put the Hyper-V role on those particular scale-out file servers and make those essentially hyper-converged, a term you may be familiar with? And the answer is yes, it'll be supported in smaller scenarios and configurations, but it is a scenario we will support. So you've got 3 options essentially. File servers, JBOD, Hyper-V cluster. So that's a separate configuration. You've got a different configuration where you've consolidated the physical disks into the file servers, and then your Hyper-V hosts are separate. Or you've got this hyper-converged configuration where you've got local disks, file server, and Hyper-V node all in one.
And that's still a cluster.
And it's still a cluster.
And it's still fully fault tolerant. It's still fully redundant.
Correct.
So shared nothing, Hyper-V storage clusters all in one box. Not even in one box, all in, with nothing shared between them, but good fast Ethernet.
So let's check it out.
So we're going to do some of that, and we're going to start it, and because this takes a little bit of time. So we've got a number of things I'm going to show you on how we build these storage spaces with direct environments. Some of this uses VMM. We're going to use PowerShell for a lot of it, but I want to show you real quick that ultimately with VMM, this is how you're going to do a lot of this. So we have under VMM here under servers, I'm going to go create a brand new file server. All right, so here's a file server cluster that VMM is going to do.
Just before you do that, though, you mentioned, we're going to use PowerShell for a lot, and some people are a little bit worried about that, and they're not as experienced in PowerShell. That's today. I mean, as we go forward as we get closer to the final release and tools like Virtual Machine Manager integrate now with obviously Windows Server 2016, and when they align, you'll find that you can do more than we are alluding to in the UI.
Yep.
Just right now in this preview stage, when things aren't 100% aligned at this point in terms of releases, that's where it's going to be important.
I want to show you where this, how some of this surfaces in VMM, so you get a sense of what that's going to look like.
Carry on.
So this is going to be my, Spaces direct cluster. Scaled file server name, let's call it Spaces 1. Needs a cluster IP address.
So is it a minimum of 4 or 5 servers? I believe it's 4.
3.
Is it 3?
Yeah, you can do a Spaces direct with 3 servers, because I'm going to do one next. And so instead of using shared storage, this is the storage configuration. Storage directly attached to each cluster node, so no shared storage. So in this example, what I'm doing, if I just switch to one of the nodes that's going to participate, on Disk Manager.
And VMM is part of System Center, right? There was just a question,
Yes.
is it a product of mine? System Center Virtual Machine Manager.
Exactly.
Yep.
So here's one of the nodes, and you can see it's simply got a bunch of just locally attached disks. So I've got, in this one, I got 4 or 3 80 gig drives that are there's offline drives sitting there in an offline state, just directly attached, plugged in disks.
Right.
Very simple, very basic.
So these could be hard drives, SSDs.
Yeah. And how they're connected to the server is irrelevant. Like, these could be in the box, or they could be, mapped directly on Fiber Channel. They could be mapped directly on iSCSI. We don't care as long as it's, this drive is for this box only. It's not a shared drive. And so we go back and just kind of let this finish out. Go to VMM. And so we hit next. Oop, too long. Pop quiz, why can't it be more than 15 characters, Matt?
I struggle with DNS, no point asking me, as you so kindly pointed out.
NetBIOS name limitation. It's a really old limitation going back to the days of like LAN manager. Run as account. And then which nodes am I going to add? So we're going to add 4 nodes. It's going to use all the direct attached storage in all those nodes to build a cluster. We hit finish, and now VMM is going to basically do everything for me.
Let's hope so.
So we'll let the job populate.
But that's not to say you couldn't do it yourself through UI.
And we're going to do it ourselves next.
Right.
But you can see that VMM, as it starts to run through, this job gets to you at 40 or 50 steps.
Right.
So provisioning the storage, provisioning the cluster, creating the volumes, creating the disk, formatting the volumes, so that all's left to do when this is finished is build a file share.
Yep.
This takes 15 minutes roughly
to
do everything it's got to do, because for some reason it reboots the nodes. I don't know why it reboots the nodes, but it reboots the nodes. I suspect that probably won't need to reboot the node at some point in the future, but right now it reboots them, which is why it takes a bit longer. So we'll let this churn. Back to you, and then we'll go back and finish this up in a few minutes.
Now, you were doing that on an existing configuration, i.e. you already had the nodes there, and VMM was just saying, OK, I'll transform those. But if you had nothing...
Well, all I've done with this is I've got 4 servers that have disks locally installed, and I've deployed the VMM agent to those servers. So VMM knows they exist.
Right.
That's all I've done.
OK.
That's the only prerequisites to doing this.
So what I'm getting at there is, if you had nothing, if you had 4 bare metal servers, you've just taken delivery, you've racked them, you've stacked them, you've networked them up, VMM, Virtual Machine Manager, has the ability to do bare metal deployment of file servers. So it can handle the step of provisioning your nodes, and then, as part of the same process, transforming them into the scale-out file server. So it's cool stuff. Anyway, back to the slide. So just to reinforce what we talked about before, those choices you've got, there's the third choice, which isn't actually on here, where you use the JBOD separate to the scale-out file server. But on the right-hand side, you've got your Hyper-V compute layer, the cluster, where you're running your virtual machines. Those virtual machines are stored on the back-end scale-out file server cluster, where those file servers contain multiple hard drives and SSDs, and we're handling the relevant distributed RAID, if you will, the storage spaces across those file servers. And it's all connected via the SMB storage fabric. On the left-hand side is those two on the right kind of jammed together. So you've enabled the Hyper-V role and the file server role on the same machine and connected those into a hyper-converged configuration. Both will be supported, but one typically small to medium-sized scale-out deployments initially, and the converged one larger, and obviously allows you to scale a little bit more independently as well. So when we think about some of those partners, you mentioned partners who are deploying today with CIB clustering boxes, but there are a lot of partners out there who've got solutions that will support Spaces Direct when Windows Server 2016 launches. So you've got familiar names, perhaps Cisco, Dell, Fujitsu, Lenovo, names you may not be as familiar with, like Quanta, Intel, obviously you'll have heard of. These are systems that will support Spaces Direct as we go forward with the product, so good to know. But you can still test on your own hardware today if you want to deploy. You can even test it in virtual machines. You know, spin up 4 VMs like Corey's got, add a load of virtual hard disks to each. Don't make them shared because you don't need to. Each VM just has its own hard disks, and then you create the scale-out file server cluster from there. So what choice should you make? Should you go for the JBOD approach? Should you go for DAS and Storage Spaces Direct? And ultimately it's up to you. The one on the right, Storage Spaces Direct, will support SATA disks, so lower cost, enterprise SATA, and non-volatile memory disks as well. So giving you more flexibility and choices you can make around that hardware specifically. And it's simple to scale with direct attached devices, so you can include them in the box. You could attach them separately as well. However, Spaces with DAS, Spaces with shared SAS on the left-hand side, you don't need 4 nodes for the scale-out file server layer. You can just do it with 2 as a minimum, and it can support dual parity redundancy with less hardware. Now, obviously, if you want to survive a single disk failure, you're going to need a certain number. This is all documented on TechNet for today as well. If you want to survive an enclosure failure, you're going to need multiple enclosures. But all of that is well documented on the TechNet and also on a wiki as well on TechNet. So both will be supported in the next release of Windows Server. So you've got flexibility to choose. If you've gone down a path today with JBOD, that's fine. If you want to embrace Spaces Direct, you can go forward in that direction as well. So what's going on under the hood? What's actually happening under that software layer where the magic is taking place? Well, you've got your physical servers at the bottom right there. You've got your software storage bus, that pool I talked about, which is essentially an aggregated view of all of the physical disks in your physical systems. And from there, you slice those disks into spaces, and on top of those, have a cluster shared volume, which gives multiple Hyper-V hosts or Hyper-V cluster nodes access to the backend storage at the same time. So multiple nodes can access the backend storage. You've got your scale-out file server. You've got your VMs running on there. Now notice that the file system is CSV, so cluster shared volume file system, with or on REFS.
Now that answers a question that came up about 500 times.
Okay.
In the previous
I was waiting
section.
for 1,000, but I will if we want to.
Well, we'll address it. 500
yeah, we'll do, yeah.
is critical. Yes, REFS works in all the scenarios NTFS worked in. On CSV volumes, on file shares, all those places you could use NTFS, you can use REFS.
Okay, that's good. That's good to know. So, as I said, Spaces Direct supports SATA disks, SAS disks, NVMe disks as well. That benefit of the REFS means that really accelerated virtual disk deployment, fixed size, and also merging as well. So there's big benefits there. Part 2 of the demo.
So let's kind of kick back, and we got a bunch of stuff I'm going to show you here. Some of these are sort of complex.
Okay.
So we're just going to we're going to cross our fingers a little bit.
Okay.
So that the VMM job is run, and what it's produced is a scale-out file server for me. And so now what I'm going to do is on this scale-out file server, have a look at the pools that are on it. So these are my storage spaces pools. There are none. I'm going to make a new one. And here's where it gets kind of cool. So this is my, let's call this one. I like swimming, so I got a 25-meter pool. Why not? It's got to have a classification.
It's a bit different, but fair enough.
Might as well be creative. But look at this. Here's all the disks it found.
Across your nodes.
Yeah, exactly. And if you look at the node it's on, if we sort by node, 3 disks per node. So it's finding all the disks, saying, hey, I've got just random disks across all these nodes. You want to make these a big distributed space? Why not? I don't know what this is. Honestly.
Right. Okay.
I asked someone many moons ago, and they went, I don't know. So we're not going to worry about it. I honestly don't know what that is.
You would probably put something in there if you were serious.
Yes, I would.
Right.
So I'll hit finish. So now it's going to go create the storage pool. The job window is going to pop up here. And so here's the storage pool going. And so this doesn't take too long. And then we're going to create a volume on that storage pool. So the storage pool is the container, and the volume is how we actually spread the data across the storage pool. So storage pool is now created. Let's go back to our fabric and our file servers. And now we're going to create we're going to manage pools. We can see the storage pool that's here. We can edit it. We can modify disks. We can see the physical disks. We can add new ones. We can change some settings. It now set a default. There we go. So
yeah, 256.
256. That's what the interleave is all about. So now what we can do is we actually create a shared folder on this. So name's going to be...
So this is something ultimately that your virtual machines will be stored in.
Correct.
Yeah.
Classification, capacity. Let's do this as a 50 gig.
50 meg.
50,000. File system, REFS. And here's the resiliency op. So this is the equivalent of doing RAID on a SAN. So you have two-way mirror, three-way mirror, which are exactly what they sound like, dual parity or single parity. So single parity is basically a RAID 5-esque configuration. Now, I hesitate to say it's a RAID 5. It's not RAID 5. But for thought purposes, think of it like a RAID 5. Two-way mirror is like a mirror. Three-way mirror is 3 copies of the data, period, across the board. Dual parity is almost like a RAID 6, what most storage guys or server guys would think of as a RAID 6. So it's all the data and then 2 parity points. But it's not implemented the same way that RAID is implemented.
Right.
But conceptually, that's it's a fair analogy. So we're going to do a finish on this. Create a new file share. And so now we basically have a file share that VMs can live on. So what I'll do now is one other quick little adjustment, and then we'll actually see that we can access that file share. So we'll let this job create. Takes, I don't know, 15 or 20 seconds usually to create the file share.
With storage spaces direct, do the servers need to be the same and the disks, or can you mix different vendors and disk sizes?
My
recommendation would be to try and keep things.
The recommendation is always consistent, but you can mix things. I don't know at what point mixing becomes dangerous. I'm sure that guidance will come out, but technically you can.
Certainly if you were hyper-converging, you'd want your Hyper-V host to be the same, certainly from a CPU perspective, if you're doing live migration.
When you start mixing all sorts of vendors, then...
But if you're just looking to try it out,
then you can, you can mix things.
It should be okay. Like I say, you can test it in virtual machines.
So now we've got this new file server object. It's got a file share on it. I'm trying to get this to slide over here. Spaces fc1.contoso.com. What I'm going to do is actually add that file server to Server Manager.
Right.
And so then I can go and actually manage permissions using Server Manager. So I'm going to go all servers.
VMM will manage permissions for you if you're ACL-ing that file share to a particular Hyper-V host.
Yep, it'll take care of all that for you.
Yep.
But I just like doing this with Server Manager just to kind of show you can. So here's the file server. And so it will actually treat that as a server that you can administer. It has shares on it, and so you can actually now go and administer those shares. And you'll see it'll add in the cluster object and add in all the nodes as well and make sure they're all healthy.
A very thorough job.
And we can come in here under shares, and we can see that new file share, which is VM share. And there's one bug in this, which is it doesn't actually ACL the share properly. So we're just going to fix that real quick. So if you are doing this, just be aware that, I don't know if this is in TP3 or not, but this is in TP. It doesn't actually put any share permissions in place.
Okay.
So you can't actually access the
shares. A minor bug.
So we're just going to do the old we don't care security method.
Excellent.
For the sake of...
Good job we had a module on security earlier this week.
It is, yes. So now discarding all our security guides, everyone full control, it'll work great.
Yeah, it's fine.
And so now we actually have a file share. And so that file server is...
And that's an REFS file share, which if you were deploying Hyper-V VMs with fixed virtual disk, it would be rapid, correct?
Yep.
Cool. So somebody was asking actually around REFS, is it ready for the mainstream? There are a number of non-supported REFS scenarios in 2012, 2012 R2. So what's your thoughts?
It has been extended a lot. 2012 R2 was when it first came out. Now it's been taken as sort of a mainstream file system. A lot of the use cases for Hyper-V, REFS is the preferred file system.
Correct.
So is it ready for mainstream? Absolutely. Are there still cases where you'd use NTFS over REFS? Yes. REFS is more for running your fabric components like VMs on than it is running your day-to-day file servers.
But I think there will be guidance published.
All the optimizations, if you look at where we've shown these optimizations for REFS, are around these VM-based workloads.
Yeah.
So here's the folder in a share on a distributed volume, and the storage for this file share is smothered, I use that word, across locally attached drives on 4 different servers that are brought together in a distributed pool, and it's using redundancy. I believe I picked two-thing parity.
Two-thing.
Yeah,
Excellent.
whatever the thing was. Two-way parity, so there's actually 2 parity bits for every bit of data that's on there. So really, really neat.
Nice. It only took you 6 weeks to build.
It only took me 6 weeks to build it.
Yeah.
So
you've seen how easy it was with System Center. Like I say, you can do it through PowerShell. You can do it through the UI as well.
So
one final thing that I want to talk about before we go to a quick break is how we overcome the challenge of workloads inside a virtualized environment trying to use more than their fair share. So we've all been there. We've got somebody, we're hosting a load of VMs. One VM sparks up and starts really driving a lot of traffic to your storage infrastructure, whether that's on the SAN, whether that's on a file server, whatever it may be. There's just VMs that want more than they should have. And then what we have to think about is, okay, how can we provide a mechanism that helps you to control that efficiently at the right level of granularity to control those noisy neighbors and make sure that everyone else gets their fair share of storage IOPS specifically. And that's where storage QoS comes in. And as I said earlier, QoS was introduced in 2012 R2, but has been significantly enhanced in 2016 going forward, to the point where we're now able to granularly manage the policies we apply to the storage backend on a virtual hard disk, a VM, which may have multiple virtual hard disks, a service, which may consist of multiple VMs, or a tenant, which may have multiple services, perspective. And we're able to define minimum, maximum IOPS. We can use fair distributions, fair distribution weightings across the policies, and it's all controlled at the back end by this policy manager that integrates nicely with this, that is part of the scale-out file server.
So in 2012 R2, storage QoS was something you set on Hyper-V, and Hyper-V did all the work. Now storage QoS is something you can define on the file server, and Hyper-V will collaboratively honor the policy of the file server.
Yep.
So it's now a collaboration between the file server and Hyper-V, so that you have, if you assign a QoS policy, you don't have to worry about, I have 15 VMs, how do I, which IOPS do I give to each each VM? Now I can say the file server gets the restriction, and Hyper-V cooperates with the file server to distribute the IO load across all the VMs and make sure that no one VM gets too much.
Yep.
You control this via policies in the file server. So it's now a collaborative relationship.
Yep. And we'll see some of those policies shortly. But if we go back to the graphic, you'll see, I just don't want to mislead anybody here. The scale-out file server cluster there at the bottom is representative of a Spaces Direct configuration, where you've just got the nodes, you've no separate JBOD. As long as it's a scale-out file server, whether you're using external JBOD, Spaces Direct, that's fine. It will still, the policies, the configuration is still the same.
The underlying topology of the file server is irrelevant.
Yeah, so we've got a few key building blocks that I want to talk about before we dive into a demo. Number one, you've got this idea of the profilers and rate limiters that exist on the compute nodes, and they're looking and communicating and interacting with the back-end scale-out file server system to understand and know what it should be applying to the relevant virtual machines, virtual hard disks, tenants, services, and so on. The scheduler, the I/O scheduler, is handling and is distributed across the storage nodes, and that's handling where the I/O should go, who should get what, how much should they get. And all of those policies that you say and you define are centralized on the policy manager. So you're saying, okay, Mr. Policy Manager, I want to make sure that Corey's VMs have 5 IOPS between them, whereas Matt's VMs have 2 million IOPS between them.
Are you standing on a box?
That's how this works, no?
Okay, there.
Anyway, next slide.
That's more like it.
So how do we respond to changing demand? What happens in a real-world scenario when we've enabled these policies for a scale-out file server? Well, you'll see I've got this graphic that doesn't animate, which is a bit of a shame, but we've got number one.
Oh, PowerPoint animation? Oh my God, I'm leaving. Goodbye, see you.
Excellent. So we'll carry on. Things will get more streamlined from here. We've got number one, measure the current capacity. So your Hyper-V VM, and this is a cycle. Remember, this isn't just a one-off process. So this cycle is happening all the time between your Hyper-V cluster and your scale-out file server cluster. These rate limiters are figuring out, okay, what is being used by this VM? What is this VM trying to do? How much IOPS is it trying to use from my backend storage infrastructure? That similarly is measured at the storage layer, measuring the capacity, the usage. It uses algorithms then to say, okay, this VM or this set of VMs or this virtual hard disk specifically is trying to use this much. We've said it can't use this much. Okay, we need to figure out what we need to do. Number four, we then apply policies back from the policy manager to the Hyper-V host that then enforce whatever we've said. So let's say, for instance, at number one, Hyper-V VM is using 1,000 IOPS. Number two says, okay, yep, I know you're using 1,000 IOPS. We know you should be using perhaps less than that. We think we need to apply a policy. We'll make sure that we'll compare and contrast them, then we'll enforce the limit. And that's a cycle that just goes round and round and round. So when we think about what a policy looks like, here's a sample policy. You'll see it's got a name, it's got a policy ID, a GUID. But the key things here are minimum IOPS, maximum IOPS, and type. Minimum, obviously self-explanatory. This VM will be guaranteed a minimum IOPS of blah. In this case, it's 100. Maximum IOPS 200. So this VM is a silver VM. So we've called that a silver VM policy that will apply to certain virtual machines, certain virtual hard disks, or certain groups of VMs. We can apply a gold policy. We can create as many policies as we want and apply them. This policy is of type multi-instance. And if we look through a graphic of what that means, a multi-instance policy is basically saying, okay, your maximum IOPS in this case is 200. It's a multi-instance policy, so all VMs that have this policy will get 200 IOPS.
This tricked me up when I first started looking at this. It's almost counterintuitive.
Right.
Single instance means the opposite of what you kind of might think it would mean.
Right.
Or multi-instance, you would think multi-instance, oh, it's a shared policy across multiple VMs. It's actually not. Multi-instance means the policy is replicated for every single VM.
Good point, yeah.
Single instance, you would think, well, this is for a single VM. No, single instance means this one policy is shared by multiple VMs.
Yeah.
So it's almost the opposite.
Yeah.
So don't let that trip you up, because it did trick me up the first time I played with this.
So if you think, okay, I'm going to create a single instance policy of maximum IOPS 200, as shown in the graphic, each VM would get 100 in there. So it distributes that resource across the VMs that are part of where that policy has been applied. And that's great for clustered workloads, a particular application, a tenant maybe. You know, as a service provider, you can use this to provide more or less IOPS to a particular customer.
You can charge them for it if you want to.
There you go. Always bringing money into it. It's not all about
well,
that.
you know,
It's about giving a service.
I'm a capitalist.
There we go, and we digress. So those are the two types of policies. Now, what does a policy look like? Well, I got my PowerShell hat on and started PowerShelling.
Oh, God.
And
Come over here. No, don't.
Oh, we're going to see it live, do you? Okay, well, these are in for reference in the slides.
You go look at the slides.
All right, there
I'll
you
look
go.
at the servers.
Okay, all right.
So what I have here is the PowerShell that's basically on this slide.
Yeah, there you go. So what I've done is essentially set you up for the demonstration. Yeah, great.
No, yeah, you want to take all the credit? Sure, you can have all the credit.
Carry on.
Here's the mouse. You want to? So I've got two policies, right, that I've defined here.
Yes.
Storage QoS policy. One is shared slowdown. The other one is individual slowdown, because I'm a pessimist as well.
Absolutely.
Both set to 100 IOPS, because I want to show you the difference between these two policies. One's a single instance, which is the shared. Like I said, it's kind of counterintuitive a little bit. Mm-hmm. The individual slowdown is the multi-instance. And then I've got two VMs on two separate Hyper-V hosts that are not in a cluster. So not in a cluster, just two completely separate Hyper-V hosts.
You would need a scale-out file server cluster. It's just the workloads.
Right, but their VHDs are stored on a scale-out file server.
Right.
Okay. So in both these cases, I have this workload 1 VM here. If I look at the settings of it, it's stored on this host called VM host 1. But everything about it is stored on a scale-out file server. All the hard disks are on a scale-out file server. Everything's on a scale-out file server. So those are the two important points. And then on the scale-out file server, and I'm just, by the way, for the scale-out file server, I'm just pointing this at any one of the nodes. That's the beauty. I'm just going to pick. Right. Just point this at any one of the nodes in the file cluster, and we can kind of look and see, well, what are the policies that are actually available in the on the file server? Okay. So these are defined up there. Now, what I can start doing is actually pulling those policy details down. So you can see it actually pulled the policy details onto the Hyper-V server, and I can now apply that to an actual VM. So we can kind of see that in action. Here's the VM, and I'm going to run the old iometer tool.
The old iometer.
It is very old.
Not this version.
Well, the iometer's been around.
Right, all right.
And so this is using literally just the default access spec. So I've done nothing fancy with it. Just run IO and display the results live. And so we run that. You can see that this particular, it should work. And we might need to defer to your slides.
What?
That's kind of bizarre. It's worked 10 seconds ago. Bear with me.
It's because you called it old.
I forgot what it was asked to do. Old iometer syndrome.
Yeah, you should have said this nice shiny new iometer.
This beautiful iometer here. I'm going to go default. And we're going to go, I did do a very, very low resolution to make this all fit. I can't even get over here now. Let me adjust that real quick. See, I had this all set up. And then I made fun of you, and I made fun of iometer, and now nothing works.
And you said I was short.
All right, so we're just going to go a little bit larger.
A little bit larger, 1024/768.
I'm dealing with a limited screen resolution.
Right.
All right, so we're going to go update right away. And we'll hit go on that guy.
Boom, there you go. Look at that.
So now she's chugging along. You can see we're getting somewhere around 150, 160 IOPS.
Where's that indicated, just for people?
So right here at the top, all managers total IO per second. This kind of 190 is about the number of IOs this is generating right now.
Yep.
Okay.
Not everyone might be familiar with iometers.
Yeah, and you know, IOs are measured a lot of different ways. The number of IOs you can generate depends on how big the write operations are, the read operations are. So the number of IOs is not directly indicative of storage performance.
No.
Because if you do big IOs, you'll do fewer of them. If you do small IOs, you'll do more of them.
Correct.
But using just the default, we can see we're getting just a baseline number of IOs, somewhere around 200. So we're going to go over and actually apply a policy to this VM. So we're going to apply this shared slowdown policy, which is a single instance policy, and it's going to limit us to 100 IOPS. So we're going to go ahead and apply that policy to that VM, and it's actually applied to each hard drive on the VM. If you look at the notion, you can see this very quickly. It's going to drop down and get below 100. So give this a little bit of time. Actually, let me apply the policy.
Well, you just applied it.
I didn't. I applied a null policy. I copied this script from your slide.
Placebo policy. No, I didn't put null in there.
I'm teasing you. So apply that policy, and you can see it drop down to below 100.
Look at that.
Right. So instantly, and I bear in mind, this is pulling the policy off the file server. Okay. So this is a shared policy. Let's go over and take a look at our other VM on our other Hyper-V host. So that's this guy right here. No, it was the other guy.
I was going to say that looks identical.
Well, they do kind of look identical. Now, right. I'm wondering if this guy's going to run, or it's going to give me that. No, this one's going. Okay, so we'll stop him. Actually, we'll let him go. So he's going to run. You can see he's going to generate as many IOs as he can. This guy's getting about 400 rough IOs. So we're now going to apply that exact.
Rough IO.
It's a packet with broken edges.
Right.
So we're going to grab that same shared slowdown policy off the file server. And you can see here we've got it, and we're going to apply that policy to this VM.
So you hadn't applied it at this point. You just applied it to the.
Now we're going to apply it. Have a look at that VM, and you can see its IO is going to drop down. But look where it went. It went to 50. So why did it go to 50? That's the question. The answer is it's a shared policy. So both VMs have been applied this shared slowdown policy. So the file server says, okay, this shared slowdown policy is 100 IOs. Anyone using this policy cannot exceed 100 IOs aggregate.
Yeah, and it might be that not everyone is trying to use their 100 at the same time.
Correct.
Yep.
So they're not going to use more than 100 aggregate. So between both of these VMs, which are on separate Hyper-V hosts, not clustered, not aware of each other, the file server is governing the I/O for those VMs. So the file server governs the I/O, the actual throughput, not Hyper-V. Hyper-V's got a limit of 100, but because it's shared in the file server knows I got 2, 100 divided by 2, 50. Cool. If I did my math correct.
Just about.
And so we can quickly adjust this and go from shared slowdown to individual slowdown and watch what happens. So we'll get that new policy, individual slowdown. Make sure we got it. There it is. And so this is a multi-instance policy. And so we're going to apply this policy. And you'll see that right away this VM here is going to bump itself way up to about 100.
Way up.
So it's effectively doubled.
Yeah.
And because this VM is now not on the same policy, the side effect of that is if we jump back over to the other Hyper-V host in the other VM, it's also going to be running. I think this is the other one. I am losing track here. No, it's not. Let me go to the other one. And here it is. This is it right here. So this one's gone to 100 as well.
Yep.
Right. So there you go. So that's the live storage QoS. Again, governed by the file server in cooperation with Hyper-V. Hyper-V enforces the throughput, but it does it based on what the file server tells it it's allowed to do based on the policy and then whoever else is using that policy. You can have as many policies as you want on the file server. You can have a policy for a tenant, a policy for a group of tenants, a policy for an individual VM, or even within a VM, a policy from different disks, because this is applied, you can tell by the PowerShell here, at the hard disk level, not the VM level. So multiple disks within a VM can actually have different policies associated with them.
Nice.
So your OS,
you've got a lot more granularity. That's
so your OS policy might be different than your SQL Server log file policy, for example.
Yeah, cool. So before we go back to a quick demo where we can monitor some of that stuff with PowerShell, I want to just talk about briefly storage QoS monitoring in general. And you'll see that that policy manager obviously is where we apply the policies for your different workloads, virtual hard disk, VMs, services, tenants, etc. But what can we get from the file server in terms of metrics and information? If we take a look here, you'll see that we can pull latency, IOPS, storage node IOPS. So all of these different metrics, a very rich set of metrics, can help us make better decisions and monitor, our storage performance across the scale-out file server infrastructure. So for instance, the PowerShell that I've kindly donated to Corey again, if you want to view all the VMs using the file server, get storage QoS flow is the PowerShell commandlet. Performance of each volume on this file server, get storage QoS volume, and then the volume that you're looking for. Obviously, if you want to be more.
You didn't donate it, I borrowed it, which means I have to give it back.
It's a team effort.
That's right.
Are you set for this one? Just want to have a look at some monitoring?
Well, there's not a whole lot to look at, but take a look down and you can see that there's a PowerShell. Essentially the file server monitors the flows of data in and out with these policies. And there's a command that you can run, get storage QoS flow, that allows you to kind of check, hey, what's the flow in any given VM right now? So you can see if VMs are at their policy level or not at their policy level, what the latency is that they're experiencing right now, and just kind of check that. So it's a simple PowerShell command to start exposing some of that data. Yeah. Storage QoS flow. Again, I've just sent that command via the sim session parameter to one of the file server nodes. I've got 3 of them. And this is all, by the way, storage space is direct. 4 disks per node with a cluster. Configures a file server cluster running dedupe with REFS.
Okay, cool. So
sorry, no dedupe, but with REFS.
So do you want to do one more quick module before?
I do, and I want to actually show one other quick thing that's completely unrelated, just because you skipped over it and didn't let me show it, and that annoyed me because I put a lot of work into it. Just for the record,
I apologize.
This is the PowerShell version of building a storage distributed spaces.
There was a demo placeholder slide, I think you'll say.
There was.
Part 2.
There was, and you just kind of went, we're sick of you, and moved on, because you like slides. So anyway, there is a PowerShell version of this, and I do have it, and it does work.
I gave it you.
You did know so.
No, you wrote that one.
I did.
Yeah, well done. So we'll do one more module, because I know that I've had multiple communication with Corey over the last couple of weeks and months, and this one, this particular area is one that he really does enjoy. So we'll give him the benefit of getting this one done. This is Storage Replica. This is a new feature coming in 2016, different from Hyper-V Replica. Okay, so remember, Hyper-V Replica replicates the virtual machines, virtual hard disk from one place to another. This Storage Replica is operating at the volume level. And there's lots of different scenarios that you can apply, and we'll walk through some of them now. But what is it? Essentially, it is synchronous, and that's a big difference from Hyper-V Replica. So this is synchronous replication that's storage agnostic, so you could be using your local D drive that's a local disk within the chassis. It could be from a file server. It could be from a fiber channel volume, whatever it may be. Storage agnostic mirroring of data across sites with crash consistent volumes, ensuring 0 data loss at the volume level. That's that synchronous replication. Now you can use async if you want, but synchronous is built in the box. Increased redundancy. So if you're thinking about, okay, I could build a cluster, a Hyper-V or a failover cluster of some sort that's stretched across geographies. So when it's synchronous, obviously it can't be drastically far apart, unless you've got incredible links. But let's say, for instance, across the river type scenarios where you're New York to New Jersey as an example. Metro distance cluster to cluster DR and stretch clusters for automated HA. So if you've got a stretch cluster, 4 nodes in New York, 4 nodes in New Jersey, synchronous replication between them. If you lost the New Jersey data center, it could fail over, vice versa. So you've got a lot of flexibility, and it's a complete solution in the box. So storage replication, including Hyper-V, storage replica support, spaces, scale-out file server, SMB3, dedupe, resilient files, all of this stuff is built into Windows Server. So it's a complete solution, and it's managed either through the UI, through PowerShell, or it will be managed through Azure Site Recovery as well, which is that automation engine in the cloud. You can fail over between sites. But let's look at some of these scenarios and a bit more information, a bit more depth, and what it provides. So from a replication perspective, block level, volume-based, synchronous and async, or async, obviously not simultaneously, for the same volume. SMB 3.1.1 is the transport to get that replicated data from A to B. Any data volume in Windows, whether it's fixed disks, any storage fabric, and we talked about the management, really giving you that end-to-end experience. So here's one that's across the river, and that river is obviously indicated on the slide by that blue wavy line. What we've got here is two Hyper-V clusters in separate data centers. Manhattan in this case, Jersey City on the right-hand side, Manhattan on the left. 2-node Hyper-V on the left, 2-node Hyper-V on the right. They're all the same cluster. So HV Plus is the name, node 1, node 2 in Manhattan, node 3, node 4 in Jersey City. Using Storage Replica to replicate the volumes that store the virtual machines across from one site to another. And because this is a single cluster, a stretched cluster, if we lost one of the locations, it would fail over to the other automatically. So we've got a lot of flexibility that's using synchronous replication in the box. And that's the Hudson River, just in case you were wondering. Cluster to cluster.
It looks very blue.
Well, you know, there you go. Cluster to cluster. In this case, we're using not necessarily a Hyper-V cluster as the example, but we've got a file server cluster in Manhattan called FS Clus, 4 nodes. We've got a DR Clus in Jersey City called DR Clus, for DR specifically, 4 nodes again. And in this case, we're replicating the file server volumes across. And in this case, should there be an outage, a disaster, we're able to fail over. But this is 2 separate clusters, so this isn't an automatic failover unless you wrote some PowerShell, wrote some workflow to automate this process. This is essentially 2 separate clusters where you're just replicating from one to another. One would obviously be in read-write, one would be in read-only mode. And in the event of a disaster, you would fail over manually and bring the workloads up on the second site. And that can be synchronous or asynchronous. Now, server to server is even possible. So I could just have 2 physical servers. I could even test this out in 2 VMs. Remember, it's just volume replication. So I could have 2 VMs, D drive on one VM, D drive on another, set up volume replication, synchronous or async, lots of flexibility. But you'll see from the graphic here, we've got the same situation across the river, server 1, server 2, and I just want to replicate the important volumes between these 2 sites, utilizing SMB3 as the transport. So it's 2 servers. Again, it's manual failover because it's not a single cluster entity, so it doesn't know how to automatically fail over, but you could, again, write some PowerShell. And again, that can be sync or async if you want. And there's scenarios where you could actually replicate 2 volumes on the same server. I'm not quite sure. Do you have any scenarios where that may be relevant? Obviously, you're typing at 50 decibels, but...
I'm sorry, were you saying something of interest? Would you like me to...
I'm hoping it's something of interest, but this could be, this is a good example. I've included it on the slide just in case Corey wasn't listening.
I wasn't,
Seed
sorry.
the data onto storage for shipment. So for instance, if you've got a big volume and you want to send it off maybe to another location that you can't replicate to, you want to get that initial seed to another location where it's not able to synchronously replicate because it's a huge amount of data. You could replicate a volume onto a spare volume that you could then extract from that server, ship it, bring it up in the second site, and then start the replication and just the delta changes. So you've got a bit of flexibility there. So it is a little bit more of a niche scenario, but certainly something you can do. And again, highlights the flexibility what you can do with Storage Replica. And it's all about the block level. So it's not saying, okay, this volume has a Word document, that's a file, we're going to replicate the file. This is not operating at that level. This is operating at the block level, under the covers. This is not DFSR. This is not DFSR. It's important to reiterate. This is replicating storage blocks underneath the file system, whether you're using CSV file system, NTFS, or REFS. So again, REFS, integrated, supported. Whether the files are in use or not, that doesn't matter. We'll still replicate those files, those blocks specifically that make up the files from one place to another. All it needs is the right IOs. It captures those IOs, replicates, acknowledges, and then things continue from there. So what are the recommendations for synchronous? Well, you need a decent network. And when I say decent, I mean rapid. Less than 5 milliseconds round trip, average latency. That's about 1,500 kilometers round trip, assuming the light speed vacuum ideal. That's obviously in perfect conditions. Reality, optical fiber does reduce by 30%. You've got to go across switches, routers, firewalls, and so on. And obviously, financially, it's not going to be applicable to everybody. But the actual synchronous replication technology is built in. Most customers end up at 30 to 50 kilometers, which is feasible for a lot of organizations. And in terms of bandwidth, well, on a gigabit per second network end-to-end, that's what you're going to need, at least, as a minimum or higher. Depends on your I/O and sharing of the pipe, so you might not have a dedicated network for synchronous replication. And learn your I/Os. We're going to publish a lot more recommendations as we go forward at the next technical preview and beyond to help you understand just how much planning, how much effort, how much infrastructure you need to make this a reality for you. So for async, obviously things are a little bit less of a specific challenge. It's a little bit more relaxed. It doesn't matter about latency because we just push the blocks across and we don't wait for an acknowledgement. Obviously with synchronous, we're waiting for that acknowledgement to come back. Network bandwidth, well, it depends on your I/O to a large extent. And if you do want to test your topology, you want to check the requirements, recommendations, you can run this test SR topology commandlet, and it will give you a nice little HTML report with some recommendations.
Now, you run this commandlet. It's important you understand what the workload is that you're actually going to be replicating, because you want to model that as much as you can.
Yeah.
So it gives you good recommendations on log size, throughput, IOPS, et cetera, et cetera.
Yeah, and we will be publishing guidance on that stuff as well.
So we'll take a look at it real quick.
Yeah, go for it.
There's two demos I'm going to show you. One I'll do now, one I'll do slightly after the break because it's a bit longer.
Okay.
The first one is just plain server-to-server replication. And the second one is an actual stretch cluster. So one cluster on one side of the river, replicate to cluster on the other side of the river. So if you have a look at the screen here, what I've got is basically two servers that have the storage replica feature installed. You can see I ran the command here to actually verify the storage replica. All that loud and annoying typing was this big elaborate command right here, which I didn't want to type live because you saw how long it took.
No, we heard.
So ordinarily you would not necessarily do this via PowerShell, but you can. As the admin tools, the RSAT tools, evolve and mature, you'll be able to do this via other methods. You can do it, for example, via failover cluster manager. You can do it via virtual machine manager, although not. We're on CTB3. You'd want CTB3 of virtual machine manager. Yeah. But you won't necessarily do this via PowerShell. But what I've got here is two servers, each with an E drive and a D drive. Okay. I'm on server 1 right now, and it's got E drive and D drive, and you can see them. And if I go to server 2. It's got E drive and D drive, and you can see them as well. And so what I'm going to do is make D drive replicate from server 1 to server 2.
Right.
And so assuming I typed everything correctly.
It is a big assumption.
That's a big assumption. So I've got a new SR partnership, and I've got some replication group names. I've got source and target, and I've got the volumes I'm going to use. That's basically what this says. Go from D drive to D drive. Give this replication relationship a name called SRVRG1.
Yep.
And E drive is the log.
And
right?
this is an example of server-to-server replication.
Correct.
No
clustering.
There's no, yeah.
And so we run that command, and it takes a couple of seconds, and I did make a typo. So on the screen right here is the exact same command I typed prior to the break. Only I hit enter significantly harder.
Right. I know. I mean, the key is actually now under the desk.
It is, yeah. But enter key through the table. And so this command, as you can see here, it's a new storage replica partnership. Source group name. The group name is just what you refer to it. And you'll notice that if you really pay attention, the destination group name, the source group name are actually different. That's fine there. It's server specific, just the group name. And then the source volume, destination volume, source log, destination log, and then how big you want the log size to be. That test storage replica command will tell you how big to make the log file.
Yep.
Log file should be on SSD, always an SSD. And then the storage can be whatever storage you're actually using.
Yep.
So this is now where the relationship's established. And if you recall, we had a D drive and an E drive on server 1, which I have, and we had a D drive and an E drive on server 2, which I don't have. That's because the D drive is now consumed by the replica.
You made me panic slightly there. I was like, uh-oh.
No, it's all good. Replica has eaten the D drive. If you look in Disk Manager, it's still there, but it's not accessible because it's part of replication.
And you don't want it to be read-write on both nodes.
Exactly. So it's completely read-only. You can't even see it. You can't access it. You can't do nothing at all. There you go. Relax.
Yeah,
I got this. I got this.
My watch will be beeping shortly.
It will. So what we're going to do now is basically do two things. So we'll take a quick look at, there's some counters in here. You say, well, how can you see replica in action? There's some counters you can use. So there's a storage, if I know my alphabet, I'll go S is after P, right? So we have a Windows storage replica statistics. So we'll throw all that stuff in there and just do a report view, and you can see there's a lot of stuff you can hear. Your log queue length is kind of a key metric because that tells you if it's keeping up or not. If that queue length consistently stays very, very high, there's no real guidance that I've seen on what's good and bad right now, but if the queue length never goes down to 0, it means there's always stuff in the queue waiting to go. And then you can see total bytes sent, total bytes received, messages sent, messages. So there's just data you can use to actually validate that storage replica is occurring. So what we're going to do now is actually throw some traffic, see the data, reverse the replication. So we're just going to copy the drivers folder from Windows up onto my D drive. So just so we have some files up there. So you can see now we've got the drivers folder. There's nothing in it. We just got the folder. I just wanted to make sure we had an actual folder. So we know there's something in there. We can also grab files if we want and throw them in there. We're not going to do that because I want this to go really, real quick. So we've now got some data on that D drive. And so what we're going to do now is reverse the replication. So to do this, we're going to switch over to server 2. And we're going to just run a set command as opposed to a new SR partnership to actually change the direction of the partnership. So new source is SRV02 as opposed to server 01, which is the original source when we created it. The replication group name on that server, which is S1RG1. So this is the name of the replication group we created on server 1. The new source volume. Sorry, the new destination computer name, which is going to be SRV01, and the new destination replication group. I need to adjust this to be server 2. So essentially what this command is doing is reversing the direction of replication. So the source is now server 1, the source replication group is server, so many servers, so little time. The new source is server 2, the new source replication group is server 2, the new destination is server 1, the new destination replication group is server 1.
Can we make, is there any way we can make that font a little bit bigger?
Oh yeah, I can probably do that. How's that guy for you?
Excellent.
All right, so we'll run that command.
Just so I can see the red text when it comes up more clearly.
Okay, sure.
It's all right.
Still waiting for the red text.
Yeah, well, you just cleared it. You did a click.
That was why the AV guy switched away, so
yeah.
we get rid of the red text.
No red text.
You'll notice now on server 2, however, D drive is back. Has my drivers folder. If I go back to server 1, D drive has magically disappeared because replication is now going the other way. So really that simple. And again, we're doing this with PowerShell. You're not going to do this with PowerShell when you put this in production. This is going to be done with VMM or failover cluster manager or server manager.
Depending on your scenario.
Right, depending on the scenario and depending on the level they take the tools to. So there you go. That is storage replication, server-to-server storage replication in a nutshell.
Cool. So that's about replicating storage. How do we start to reduce our storage consumption? And one of the ways that we do that is through deduplication. And dedupe was actually introduced in previous versions of Windows Server, so 2012, enhanced in 2012 R2. But if you look here, 2012 R2, when it comes to deduplication, so if you're not familiar, deduplicating matched blocks of data on the system, rather than keep lots of copies of the same blocks of data, let's deduplicate them and reclaim that space. And we can use it for other things. So we can see quite significant savings of storage depending on the type of data that is being deduplicated. So for instance, virtual hard disks in a library, for instance, lots of templates, they can see quite significant savings. Video files probably wouldn't see as much or anywhere near as much. So, but there's some key characteristics of 2012 R2. So to scale, when we ask you to scale up deduplication, you would instructed, or perhaps the best practice guidance, was to distribute files across multiple volumes no larger than 8 to 10 terabytes each. So if you had 60 terabytes of data that you wanted to deduplicate, that's quite a few volumes you would have to create, enable dedupe on each one, distribute your files across those volumes, and then you would see the savings. Optimization-wise, whenever you're performing an optimization job, i.e. you are deduplicating, it's per volume, and that is tied to a single CPU in a single I/O queue, which means if you had a large amount of data to deduplicate, that could take quite a lot of time. And
in real terms, we did 30 terabytes on 2012 R2, like 3 days, I think it took.
Right.
It was a while.
And you sat there the whole time? The
entire time with a cup of coffee. And by the time it finished, it was horrid. It was horrid.
There you go.
But yeah, it took a long time.
Yeah, and that's the key thing, is it's only scheduling across that single CPU. Obviously, if you distributed it across a few of the volumes, you can utilize more, but it's a manual configuration per volume as well if you want backup support. And you'll say, well, what is backup support in deduplication? Well, we've talked a lot about scale-out file server today, and if you use the scale-out file server as your backend for System Center Data Protection Manager, so you've got System Center Data Protection Manager, which is a backup solution as part of System Center. It is virtualized itself, and DPM's virtual disks are providing the storage for the backup that you're taking of your workloads and applications. Those virtual disks that DPM is using for its backup are stored on a scale-out file server volume. If you enable deduplication on that volume, on the scale-out file server, you can then essentially deduplicate your backups. It's a roundabout way of achieving deduplicated backup. It's a little bit cumbersome to set up, very manual, a bit of PowerShell here and there. In 2016, things have changed quite considerably, and if we remove, if I want to see the animation now, I've put a big white box with a question mark in it just to hide it, because I don't know how to fade rows of a table and columns at the same time, so I just put a square over the top.
I mean, I could have done it in PowerShell for you.
We'll move on. With Windows Server 2016, you'll see the volume a lot bigger. So it means you don't need to essentially say, OK, I'm going to distribute these files across these volumes in order to meet some kind of scalability requirement. Big volumes, put all your data on those volumes, how you see fit, up to 64 terabytes, which we feel is enough for most people. And then it will deduplicate at that size. And one of the reasons it can now scale so well is it's multi-threaded per volume, which means all files optimized in parallel, load balancing across the volume itself, across the CPUs and threads. And that means it's a lot more efficient. And when it comes to backup, so that backup scenario where you've got DPM protecting your workloads, its storage for its backups are stored on the scale-out file server. That is now an integrated usage type through the UI, so it's a lot more efficient. And I guess you've got some experiences.
Yeah, well, I haven't done a 32 terabyte scale test of this one yet, but we did do a little test a couple of days ago, and I think it was 70 or 80 gigs. It was about 2 minutes.
Right.
Dedupe. So I mean, you just multiply it up to the scale. That 32 terabytes would take hours, not days.
Right.
So the performance improvements are very, very noticeable.
So should we have a quick look?
Yeah, so take a quick look here. So this is just an example I worked up, which is, the world's worst file server user. I just got a copy of files, but they're not Word docs, they're 8 gig VHDs. Just to kind of illustrate how you go about setting up managing some of the deduplication components. So number one, this is installed via Server Manager. It's simply a role you install. There's nothing special. You just install the dedupe role. It's got to be on the server. Is that a
role or a feature?
Sorry, feature. So it's a feature. Good point. Once you install it, well, you need something. You close Server Manager and open it again so that Server Manager understands it was installed.
Right.
And then you can take a volume and you can actually enable deduplication on that volume. So we have this new option which is called Configure Data Deduplication.
Yep.
And we can now choose the role, General Purpose File Server, VDI, which is a good use case for it. For in VDI you have gold images and then the actual VHDs that represent the running virtual desktops. That could be deduped, but there's also now the new virtualized backup server, which is the use case you were just talking about there. File extensions, we pick General Purpose File Server here. Anything you want to exclude, and then the schedule. This is a pretty important note right here. Deduplicate files older than X days. Most of the time, if you have files that are going to change on a very, very frequent basis, you probably don't want to dedupe them every time they're touched. So you can, figure out, hey, if it's a week old, we'll dedupe it. If it's less than a week old, we assume it's going to change. Kind of that, how long does it sit there idle before we consider it long-term idle?
Yeah.
I set it to 0 because I want to dedupe stuff right now.
Yep. Very impatient.
I am indeed.
Right.
And then to actually manage deduplication, it's going to run on a schedule. You can figure what the schedule is in here as to when dedupe's going to run, and also how aggressively it's going to run. So there's basic optimization, there's also throughput optimization. Throughput optimization will consume much more CPU, much more disk. It'll go as hard and as fast as it can, but you can also have a secondary type, which is just background optimization, which it will run in the background. If someone touches a file, dedupe pauses. So it basically only runs during idle time, and you can edit a couple of schedules when you want this to happen based on when your servers are active or not active.
Nice.
And then to actually use deduplication, it's basic PowerShell. And so I've got a couple of things. Look, some of you are wonderful red text.
Yeah.
That you love seeing.
Very familiar.
Yes, indeed. So we've got a bunch of things in here that we're going to take a look at. Let me just clear this out. So we have dedupe status. Kind of shows us, hey, do we have anything currently active right now? So we know that we have one volume. It's dedupe. We saved 72 gigs of space by running dedupe over 14 files.
Right.
Now I've got a bunch of copies of the same VHD, so we expect it to be very good.
Yeah. But
if you have, for example, a VHD library or a WIM file library,
even if they're slightly different,
yeah, you're still going to get phenomenal space savings. Our VHD libraries, which are sort of lab environments, demo environments, we realized upwards of like 85% space utilization by putting dedupe in place. Right. So pretty significant. And then you can have a series of PowerShell commands. Just to do things like start a job, run a job, schedule a job, all those things you could do. And if you want to run dedupe right now, you can actually start a dedupe job. Type optimization, which means run the deduplication. Volume that you want to run it on, and away you go, and it'll actually run a dedupe. I'm not going to run it. This will do nothing because I've already deduped the volume.
Yeah.
This one took about 6 minutes to do the dedupe on.
Nice. But it is spread across the cores. It's spread
across all the cores. You see all cores being active. And then finally, when it's done, we can actually look at some of the statistics on it. And you can actually see the free space on this one. Sorry, the use space is only 5 gigs.
Even though one virtual hard disk is bigger than
correct.
5.7.
Duplication savings 72 gigs. Deduplication rate 93%.
Nice.
So very, very efficient.
Yeah.
When you combine dedupe and storage tiering, you get something that's real special. Storage tiering, which we didn't cover in here because it's existing in 2012 R2, allows you to have some SSDs, some hard drives, and then the hot blocks get moved to SSD. If you dedupe that volume, your hit rate goes through the roof, because if you have 50 files that have been deduped down to 1 or 2 blocks, you now get all 50 files in hot storage as opposed to 2 or 3 of those files in hot storage. So your hit ratio of hitting the blocks you need on hot storage goes up tremendously when you've deduped on storage tiering. So there you go. That's the basics of how you implement configure dedupe.
Nice. So in the interest of time, I'm going to wrap up this storage module. It's been a blast to see a lot of those PowerShell.
So one thing I will mention, one demo we did skip that I did want to do, and just in the interest of time, was the stretch cluster. And I did commit to Matt. I will record that as a video. You can throw it on your blog.
Thanks.
And hopefully that'll generate some traffic, because I know you're struggling right now.
Well, absolutely. I'll take anything, and we can tweet out to Corey's follower. So resources, wrap up, just for this particular module. Don't go anywhere. This isn't the end of the resources for the course. I just want to make sure that you're aware that the storage team, they want to listen to you. If you've got something you think, okay, I've learned a bit about storage today, I've learned about Replica and dedupe and all that cool stuff, I think it would be great if it did this. Obviously, we may not have talked about everything that particular feature does in the interest of time, but there is a way for you to raise your voice and say, look, I'd like to request this feature. And if enough of you find it valuable, then chances are it might get implemented in a future release or a future update of the product. So there's also a few deployment experience guides there that help you set up this kind of stuff. And obviously they will be getting revved and updated as we move forward to the next preview release, which will be Technical Preview 3. Those the ones on the slide will currently link to TP2. And that brings us to the end of our software-defined storage journey. So hopefully you found that very useful indeed. There was a lot to comprehend: storage replica, deduplication, storage spaces direct, storage QoS, a whole host of cool stuff that I think...
There's a lot of things in there, for the average admin to be able to now do that maybe they couldn't do before.
Yep.
Because it was so hardware-driven. Well, you can do it all in software, so that's great.
Cool. So that concludes this software-defined storage module. But please join us in the next module, where we're going to be talking all about software-defined networking. See you then.